From Microbe TV, this is Office Hours for Wednesday, January 22, 2025. I'm Vincent Racaniello, and welcome to your viral corner of the internet. Let me turn on my disco phage there. Come on. Go on. Mark. Okay. Courtesy of Mark Martin. Welcome, everyone. Jesus, it's so cold here. In the Northeast, it's minus 14°C. I was running around today outdoors. I'm so glad to be inside. We have a lot of things to talk about tonight. I have a mini lecture for you. I have some other things, as you might imagine. No shortage of things to talk about. But first, tell us where you're from. We'll shout you out. And let's see our moderators here tonight. We have Barb Mack from the UK, second duty. She was on Tweevo today. Thank you, Barb Mack. Tom Steinberg from Madison, Wisconsin today. Steph SF, 63F. I don't want to hear about it. It's terrible. See, what was cool was about how if you injure ants' legs, the workers will amputate the leg to save the ant's life. Very interesting stuff. But today we have viral stuff. We have tonight. Who's here? Rita Ramon from the Ramones. Where is Rita? Somewhere out west, maybe Idaho, something like that. Wayne, welcome. I don't know where you're from. I don't remember. But Rach is from the Isle of Man. Welcome, Rach. Yes, Rita. There's going to be a lot to rant about today. Who knows where WHO is? Does anyone know where it's located, where the headquarters are? I've been there many times. Hello, Chris K, wherever you are. Eliza is in southern Ontario, minus 15°C with snow. You beat us here. Oh, yes, southwestern Idaho, 0°C, no wind. Dagfinn is in Oslo, Norway, minus 5°C. Thanks to all of you for coming. Wayne is in Urbana, Illinois. Visto, good day, Virobes. A chilly 23°C in Sydney today. Not as chilly as here. Elizabeth is in West Virginia, minus 14°C, matching the temperature here in New Jersey today. Patricia, it's so cold. I barely have any energy. I'm so tired. Good evening. Yeah, the cold takes the energy out of you. But remarkably, so I did a Tweevo today. Then I went uptown to do my virology class, the first class of the semester. The room is packed full of people. Lots of people on the wait list want to get in. It was very energizing. So I gave that lecture, rushed to the subway, got on the train here just in time to have a bite to eat and do office hours. Now, tonight it worked out. Not going to work out all the time. By the way, in the process of setting up tonight, I got rid of the blue border. I don't remember how to put it back, and I ran out of time. Unbelievable. Unbelievable. I have a license to rant. Bernard is in Brooklyn, where it's very cold. Yeah. Pete's in London, 2°C. Got a storm heading out there. Will is in Changsha, 11°C. And the air quality index of 260. Kang is in Chicago, where it's minus 6 with light snow. Carol, hello, our favorite nephrologist from Bakersfield, California, 58F, 14°C. Nice and warm. It's good. Elena is in Westchester. Yeah, it's cold around here. Questella is from Ohio. Welcome, Questella. Abhilash is in Frankfurt, 2°C and raining. Heading to Freiburg and at the end of February for a meeting, pandemic something or other meeting, to do a podcast as well. And of course, Barb Mack is in the UK, West Midlands, 1°C. Patricia says here, RFK, Mr. Trump's nominee for HHS secretary, will keep financial stake he holds in litigation against Merck. Yeah, it's just so slimy. Just liars left and right. There's Tom from Madison, Wisconsin. Jessica from Ohio. I love you all. Glad we have this safe space to discuss science. Yeah, it is here. Although people try and disrupt it all the time. Some guy this afternoon was trying to disrupt. Just leave us alone. Go away. If you don't have anything good to say. Margot is in Phoenix Metro 56F. Very nice. Steph SF is in San Francisco. High of 63. Krishnan is in Malaysia, where I bet it's really hot. Oh, it's an interesting one. This is a new person. Michael Layton's Carl Pilkington Animations. Welcome to Office Hours. It's an interesting name, company. Betty K from Washington Heights. Welcome back. Angry Penguin, Toronto, minus 11C. Rabbits are eating birdseed. The ranting began. Oh, maybe I'm so tired from the cold I don't have energy to rant. Do you think that could be true? V. Renken is in Dallas, Texas. Julie S. is in North Central Pennsylvania, where it's 13F. MN is near D.C., and Jessica is at the University of Toledo in Ohio, 13F. Hans, nice to see you, Vincent. It's a sad day. Trump's blocked all CDC science reports, so suspended all CDC, FDA, NIH external communications, including all health alert warnings. Yeah, we'll talk about that. It's just, it's just nonsense. He's a person who does not deserve to lead anything. John, minus 6C in Minneapolis, Minnesota. Les, or another moderator. Welcome, Les, from California. Jonathan is from Encinitas, 19C. That's quite nice. Mike and Lori are in Seattle, where it's 38F. A little chilly. PGL Patty in Massachusetts. Jem is in Hampton, Virginia. Laura is in Washington, Pennsylvania. Stephanie is in Seal Beach, California, where it's 71F. Hope you're okay. You're not near any fires. EHS Talent is in eastern Pennsylvania. Logotic warmed up to minus 6 today in Chicago. Did someone say? Here's the first answer. Wayne says the WHO HQ is Geneva. That's correct. Hans is in Guayaquil, Ecuador, 29C. That's pretty warm. I'd like to be there. I'd like to be somewhere warm. Rach. 100-mile-an-hour winds on Friday. We already lost hundreds of trees in the last storm. I'm so sad for all of you dealing with Trump's ludicrous plans. They're embarrassing. He doesn't care. He just doesn't care. No allergen alerts, no food warnings, nothing like that. Nothing. You're not going to get any communications. Plus, because we jumped out of WHO, we're not going to get any info for WHO from them either. But we'll talk about that. Jessica says, I heard study sections were halted. Yeah, so I saw some texts today saying it. I mean, it's all part of the shutdown of communication. I don't know how long it's going to last. We'll see. Michael's in Wales, 24C. 82F in Irvine. That's nice. I like that. Lise is in Columbus, Ohio. Just darn cold. Yep. Tona is in Long Island. Welcome back. Silent Rudders in Wichita, Kansas, where it's Minus 23C. That's pretty darn cold. Yeah, that's very cold. Confirmation hearing has been set. It is, let's see, I pull up my text. Next week, something like that. Well, who sent it to me? Now I can't even remember who sent it to me. Sometime it's been set for I think next Wednesday. A week from today. Yeah. Who sent it to me? Who sent it? Anyways, next Wednesday. What do we got here? Abdul Rahman, hello from Manhattan. Nice to see you again. Maureen is in Ohio. Very cold. And Les says, glad to see RFK Jr. still wants to make cervical cancer great again. Patricia, 15F. Truman, 17. 5C and dropping in Fort Worth. It's okay to rant about the truth. Well, if someone is saying the opposite, yeah, I'm going to rant. It's ridiculous. This whole situation is ridiculous. And also, there's going to be a ban on, and next week's proclamation of Trump will be a ban on certain kinds of experiments. But we won't talk about that now because we don't have the details, although I could tell you what it's about. Hello, H. Zoo. Nice to see you. Minus 3C in Austin. That's really cold. Yeah, you can visit the incubator. Just email me at vincent@microbe.tv and tell me when you're going to be here just to make sure I'm around. I usually am, but now and then I teach, I have podcasts, I travel. So just let me know. But you are absolutely welcome to visit for sure. Helen is at the Winter Green Ski Resort in the Blue Ridge Mountains where it's 9F. That's very nice. Can you as states or cities join the WHO? That's an interesting question. Who can join the WHO? Let's see. Who can join who? No. Yeah, a city or a national network. You have to meet specific requirements. Well, that's for the European cities network. Maybe. That would be interesting. So I know a lot of states would join, right? Magpie McBee from San Diego. We're at 64F. Welcome. Welcome. And hello, Laura. Kip and Laura Potter. Thank you for your contribution to science communication. San Francisco 59F. It's lovely. Carl Pilkington is hilarious, Vincent. Carl is a well-known comedian in the UK. Friends with Ricky Gervais. Oh, that's cool. So Michael is associated with Carl Pilkington Animations. Cool. I'm glad to see you here. Star Climber, 2 degrees C in Surrey, BC, Canada. Tona, I still have hope RFK won't be confirmed. So it was delayed, I think, because there is some concern about getting enough votes. Yeah, and of all of them, he's the worst. So I would, if I could only have one not be confirmed, that would be him. But I'm telling you, Jay Bhattacharya, horrible. Horrible, horrible. Not a scientist. All right, Carol's leaving to go to a meeting. See you later. You can watch later. Can the public attend this skinny tie hearing? I think it's going to be publicized, yeah, but I don't know exactly where. Patricia's in Massachusetts. And David says we build a blood-brain barrier and make the brain pay for it. That's right, with stupid. Jin Yuan Mu from China, welcome. Great to have you. Tatiana Beast Mode in Birmingham, Alabama, where it's minus 2C. Abdul Rahman. Of course you can visit. Everyone can visit. Just email me, Vincent@microbe.tv, to arrange a time. That's all. I will give you a nice tour. We'll sit you down in the recording chair and take nice pictures with lights. Nice lights all over. It'll be cool. I can tell you stories. Evander is from Michoacan, Mexico. Michoacan. 27C. Cheryl is in Santa Rosa, where it's 61F. And Tona says, imagine if all the Twivers were heads of WHO in their respective states. Brian for New Jersey, Vincent for the New York WHO division. That's cool. Helen says, confirmation hearings are on C-SPAN. I don't know how you get C-SPAN. Gallbladder. Bill A is Bill in Baton Rouge. We're at 7F this morning and 8 inches of snow. Wow. It's a lot of snow for down there. Yep. All right, here's a question from Kang. Since humans infected with bovine H5N1 flu have benign outcomes, could a vaccine for H5N1 be made from cows and be effective as the cowpox vaccine against smallpox? Okay. So the problem is that we don't know, how far away bovine H5N1 is from being virulent. How many base changes would it take to become virulent? So those studies should be done. We have to do some research, and I'm sure they'll get flagged as gain of function and be restricted according to the upcoming edict from the emperor. I would not want to take it as it is. It depends on how many changes, say, compared to the avian, which was the direct precursor of it, which is virulent in people. So I think those studies should be done first. And I mean, if there are a lot of changes and it seems like it would be stable, you'd have to do stability studies. It's not a bad idea. Yeah. Ito 2000 was in Cincinnati, where it's minus 10C. Luis Cardenas is in Mexico City, where it is 19C. John says, I like the WHO idea. If they don't currently have a way to onboard individual states, they should be asked to develop one. Yeah, I agree. So C-SPAN, there's the link for C-SPAN, but Star Climber says it streams on YouTube. There you go. You can watch it. It's an interesting question of which states would join who if they could, right? I'm sure Massachusetts would. New York, yeah. It would be driven by Manhattan, which is always the liberal part of New York State. Minnesota. Don't you think California would be interested? I think New Jersey would be as well. Matthew says, greetings. I hope we keep up with our COVID vaccine so we cannot allow this to come back regardless of what is going on. The blinking phage on the mantle looks like it's hearing some great music. Yeah. Unfortunately, it's just blinking to itself. Armoda says he or she, I heard H5N1 will be exempt from bans. I don't know. It depends on the details. Let's wait until the announcement, the edict comes out. We'll talk about it next week. So D1 Oliver says, is WHO really integral to public health in the U.S.? I feel like CDC serves most of the functions. Well, CDC gets data from WHO. Global data, which helps it. So I think it's going to miss out on a lot of information. Yeah. Again, I want to talk about that in some detail. Hello, Gwen. Gwen, I remembered. I didn't even look at it written down. Cold Michigan. Bernard thinks Illinois would probably join. But supposedly it has to be a sovereign state. So we don't qualify. We all have to secede from the Union. Luis wants to know, hi, Professor, I have a question. Is it common to design an antiviral and some mutations can lead to resistance? And is there an average value for this to occur? So most antivirals, you will get resistance eventually, yes. It depends on the fitness. So the resistant viruses need to be fit in order to survive. So we don't see a lot of resistance to Paxlovid. It's interesting. Apparently, the viruses are not very fit. What is there an average value? Well, RNA viruses mutate, make mistakes in their polymerase in about 1 in every 10,000 bases. So it can be very high. You can do a plaque assay with an antiviral drug, and you pick one plaque out of 10,000, and it could be resistant. But I think it's different for different viruses and different antivirals as well. Truth or Dare is in La Jolla. Estelle said my 7-year-old just got a COVID booster, and the nurses there were looking at me like I was crazy and saying they didn't think we people were still doing that. Don't let them make you feel bad. That's the right thing to do. They don't know anything. They're just listening to hearsay. I'm sorry to say that because, nurses are important, but nurses and docs are important, but they often are misled. They have misinformation. Oh my gosh. Costello, you want to succeed, but you want to secede, right? Secede from the Union. Will data still flow from USA to WHO? I doubt it. He may prevent it, right? He said, no, don't give you anything to WHO. All right, Pete, you're good question, but I'm going to ask it later. TC-SPAN is a private, non-profit public service created by the cable television industry. I think it's okay. It's a non-profit. What's this pause about? Yeah, I'll talk to you about it. Yeah. Can I carry my card that inactivates norovirus? There's nothing. Nothing will inactivate it. Truth or Dare says, not a fan of politically appointed leadership of CDC, WHO, especially after reading Laurie Garrett's betrayal of trust and Michael Lewis's The Premonition. I agree. I don't think a lot of these public health positions should be politically appointed. I think that now you're seeing the problems with that. I think it's a real problem. All right, let's do a little chatting about WHO first. So this is the actual presidential executive order. So pompous. It's like less than a page. They can't write. So this is so stupid. It's hereby ordered. Section 1 purpose. The U.S. noticed its withdrawal from WHO in 2020. It noticed? What do you mean it noticed? It did it. Come on. And they say mishandling of COVID pandemic, other global health crises, failure to adopt urgently needed reforms, and inability to demonstrate independence from the inappropriate political influence of WHO member states. And they say that the payment is too much. They say China contributes 90% less to WHO. Well, guess what? That's not right. So here's an article in The Guardian. This is by Gordon Brown. Memo to Trump, you were wrong to leave WHO. You should think again. We'll need the WHO to fight the next pandemic. So, I want to get to this interesting part. So the WHO was founded in 1948 by the United Nations, right? And it's been there for a long time. All right, so Trump says we shoulder too much of the burden of WHO expenditure, okay? So the official executive order, as I showed you, says China with a population of 1.4 billion has 300% of the population of the U.S., yet contributes nearly 90% less to WHO. They pay 39 million, we pay 500. But he got its facts wrong. In fact, USA pays 130 million in assessed contributions, and China pays 88 million. Right, so it's not as disparate as he says. So are you surprised that he would get the facts wrong? So what is this link? Let's see what this is. Yeah, it's a WHO document which tells you how much each country paid, so you can go look at it. And I assume he quoted it properly. All right. So that throws out the financial stuff. And so what are we left with? Mishandling of COVID-19. Like what? Everybody made mistakes. So your reaction is to pull out instead of saying, let's work together and fix it? No, but that's not what he does. He just he penalizes you. So here we are. I don't know about other global health crises. I mean, they do very well with Ebola. They do very well with Mpox and monkeypox virus. So anyway, so, you know, they they withdrew in 2020, and then Biden put us back in, I believe. And now he wants to do it again. According to this, the assistant to the president shall establish directorates and coordinating mechanisms to safeguard public health and fortify biosecurity. Yeah, I trust you. Like you know what you're talking about. So this is basically a we think you screwed up, and we are going to punish you for it. That's the Trump administration way, right? It's punitive. And you're going to see that over and over again. It's why Biden preemptively pardoned Tony Fauci, right? And a number of other people who he said, you know, we don't have any charges against them. They haven't been convicted. But I'm doing this in case someone wants to do something against them. It's a preemptive pardon. It does not mean they've done anything. Whereas when Trump pardoned 1,600 people who participated in the January 6th riots, that's an acknowledgement of their guilt because they were convicted. And by the way, you see the old lady, the granny, I think she lives in the UK. She said, I don't want this pardon. I served my time. What we did was wrong. The whole thing was wrong, and there shouldn't be any pardons. That's great. I just love it. I mean, and then you pardon the guy who used to run Silk Road and sell heroin and cocaine and other drugs online who's in jail. I mean, why do you have to pardon these people? Doesn't make any sense. This is funny. Some of these comments here. Someone who said here, mistakes like advising bleach injections. Yeah, and forcing FDA to license or EUA hydroxychloroquine without a human clinical trial. Just bullied them into doing it, and it caused a lot of damage. That is a mistake. So we should stop paying him, right? Star Climber. I think we all know who really mishandled COVID-19. So, you know, early in the pandemic, and this is embarrassing, Trump said, oh, there are 12 cases and they're getting better and pretty soon they'll be gone. He said it was all going to go away, you know, which is just stupid because nobody had a crystal ball. And that's the problem I have with Bhattacharya. He said, oh, we don't have to mask. We don't have to lock down. It's not going to be any big deal. He didn't know. He didn't know that people would get long COVID. So when you don't know things about something new, you exercise caution. You don't write a great Barrington Declaration and say, we don't have to do any of these things. That's not the way science works in public health. This is why he should not be head of NIH. It's pathetic. And any scientist who thinks he's okay is pathetic as well, because you're not thinking about it properly. So the WHO thing, I think, is pathetic. It's ridiculous for him. What are we paying? $130 million a year? Seriously? For that you're bumping out? Or you just want to run the thing yourself? No, it's not the way it works. Nations join, you listen to what they say. You have discussions and you work it out. It's not the Trump way where you just fire people. So it's a waste. It's really stupid to have quit. And I don't know how we can put it back. This idea of presidential proclamations is kind of ridiculous, because why should he have the power to do one thing? That's the way it is, unfortunately. But could someone sue to reverse it? Yeah, go to the Supreme Court, and then the Supreme Court will vote on his side. So it's really screwed up. Yeah, it's really screwed up. Yes, it's the second time ahead of WHO, right? Questella, you hate it here. Yes, but we need to fight back. We cannot let them win with misinformation. And we can't just run away and hide, blah, blah, blah. We have to fight it and show that there are people here that believe in the truth. Hello, Markle is in icy Long Island. Is it true that the state of Florida is going to prosecute Dr. Fauci? They can't anymore. He got preemptive pardon. You can't prosecute him. Yeah, they would like to, but they're idiots to try and do that because he didn't do anything wrong. Patricia, we got to do away with executive orders and pardons, devolve power back to Congress. I agree. I think this idea of putting it in the president is ridiculous. I don't care who the president is. She shouldn't have the power to do this crap. All right, so that's WHO. I think it's a mistake, obviously, but here we are. I don't know what's going to be the outcome of this. Now, the other thing he did is, let's see, I have another article here. Trump administration directs federal health agencies to pause communications. So this is CNN Health. So they can't do any more communications, which include scientific reports, MMWR, emerging infectious diseases, can't publish them anymore. Updates to websites and health advisories. No, you can't get any food allergy or can't say, there's an outbreak of norovirus in this state associated with this. You're not going to get that anymore. And this includes HHS, FDA, CDC, NIH, and includes regulations, guidance notices, social media, websites, and press releases. They have to be approved by a presidential appointee before issuing them. And you can't engage in any public speaking engagements without approval. And you have to have it approved by a presidential appointee. So that this is its plan for managing the federal policy and public communications processes. It's not a plan for managing it. It's a plan to censor it. If they don't say what you want, you can't say it. So for them to say manage is just lying outright, and it's disgusting that they would do so. I just despise that kind of behavior. A source familiar with the directive said it wasn't entirely unheard of, but the scope appeared to be unusual. And another said that there were no restrictions on communications of the last two administrations. So here's the thing. CDC, FDA, NIH routinely release information on food recalls, drug and medical device approvals, updates on evolving public health threats, including natural disasters and infectious diseases. Many of the agencies have been tracking H5N1, right? It's really important. So you can't get any of that information any longer. I depend on that every week. I go to CDC website and find out about what's going on with different viruses in the U.S., and we can't do that anymore. Temporary pause in the flow of information should not be cause for concern. Temporary? I don't know. Is it going to be temporary? Anyway, so that's the other thing that he did this week. WHO and this. Of course, many other things as well, but they don't fall under the purview of science and public health, so we're not going to talk about them. Although you can bring them up. It's fine. Yeah, democracy. Democracy. Fighting is better than fact-checking. They don't care if the justification is bogus as long as debating it wastes time. Yeah, unfortunately true. Polka.pup says, I asked my Texas doctor for a script for Paxlovid. She said her office didn't think it worked. In Southern girl fashion, I said, you're so sweet, I'll take the prescription anyway. That was the right thing to say. We didn't think it worked. All you have to do is go to the AMA website or whatever it is that Daniel keeps telling people to go to and see what the recommendations are. Jeez, no communications among doctors and information sources. It's crazy. So no CDC tracking of diseases, wastewater. Well, they may still track, but they won't let you know what they find. Athens writes, he will next pull us out of the ISS because the Earth is flat and space isn't real. It's a waste of money. I don't know about Doge, but Athens says the difference between the Government Accountability Office and Doge is that Doge is redundant. They also are so inefficient that they appointed 2 heads instead of just 1. Well, you know, he also wants to take away rights from transgender individuals. Many other, you know, there's a baloney with him starting this crypto fund, so now people can bribe him without being detected. It's disgusting, absolutely disgusting. And half of the America voted for this. It's very shameful, very shameful. At least we have wastewater from independent sources. You mean other state health agencies? Yeah. I don't know if they're going to be quashed by CDC or not. It's an interesting question. Jeff writes that the president has so much power is due to Congress being lazy a long time ago, allowing the president to declare war when the Constitution is clear that only Congress has that power. Yeah, that's absolutely true. I'm no politician, but I know the Constitution says only Congress can declare war, but in fact, presidents declare it all the time, and there's nothing to be done. Nothing to be done. What's the penalty for disobeying any of these nonsense orders as a federal employee? I don't know. They didn't say, but could be getting fired. Sure, I wouldn't be surprised. Yeah. Or maybe therapy. You have to have training so you don't do this again. Want to bet a whole lot of federal workers quit soon? Sorry. Yeah, I do. Sorry, I thought I was sharing my screen, but let me go back to what I was sharing. So, yeah, that's the Trump. This is a CNN Health. Trump administration directs federal health agencies to pause communications. That's what I was reading from. And I was also reading from the White House executive order withdrawing the U.S. from WHO. And I was also reading from this Guardian article by Gordon Brown, who says he shouldn't leave. And in fact, his money is off. The U.S. pays $139 million and $130 million, and China pays 88. So it's not so much of a disparity. So that throws one of his arguments out the window. Are you surprised that he portrays it wrong? No, that's the way he is. Just get it wrong to serve your purposes. Spamlet. It's hot here in Beds, UK. Okay. Sewer connoisseur writes, what are we risking by allowing raw milk? Is there a difference in risk if we allow single cow raw milk instead of giant batches? It depends on how you trust the testing, even of single cow, right? There have been outbreaks of milk-borne outbreaks of infectious diseases, even from, small farms. So I don't think it's worth the risk. Why do you have to drink raw milk when there's any kind of a risk? I don't get it. Patricia says, just to be clear, no web updates on Mpox, COVID, flu, H5, HPV, right? No wastewater. No updates. We're not going to get them. Presumably they'll still be looking, but they're not going to let us know. No. So I'm looking at Will here, who said the prof of global public health at Edinburgh said it right at the start, and I don't know where the rest of it is. Oh, here it is. Too much fear of overreaction. Better to react and prevent something than wait and have to treat it later. Being blamed later for overreacting comes with the territory. Meet Michael. Hello from Mexico City, 18C. Welcome. I see. Spamlet. I had a feeling that pardons would only apply to federal crimes. Okay. All states might find charges to make against Tony F. I don't know how you could make anything stand up against him. It's totally ridiculous. If you do, then it's really ignorant. It's really ignorant. Paul Offit was on with Dr. Dan Wilson. Debunked, very good, but concerning. Yeah, well, we've known that for some time. And I'm still doing Beyond the Noise every week with Paul Offit. We were put back on YouTube. So I have number 50 to release this week. Probably do that tomorrow. Martha's snowed in Charleston. Steph, can you think of any alternative methods for communication to the public for public health issues? All right, so we have little people like Microbe TV, right? We have limited resources, so we can't do a lot, but we can do something. I do think there should be a network that is nonprofit, non-politically affiliated, that, C-SPAN is a nonprofit that broadcasts stuff that happens in Congress, right? There should be a nonprofit that broadcasts information about public health, unbiased. Is it possible in this world? But who's going to pay for this? Not going to make a lot of money, right? Well, maybe it would, because it would be the only source of truth. Because, they're going to censor, the administration is going to censor everything that's coming out of HHS for sure. totally censoring you're not going to know what's going on anymore. It's really sad. Lugotic says the pause in public health updates will last only until the first news reports of a bunch of people dying from contaminated lettuce or some such. Well, if that happens, then the representatives and senators from those states need to stand up in Congress and say, we demand that you open up this information again so that we can learn what's going on. They have to show some chutzpah, these Congress people. Not just, I know that, a little less than half are Democrats and they want to do the right thing, but the other side, do the better thing, okay? Call for the information. Information needs to be out there. There's zero reason to censor scientific information, which is what's being done now. There's zero reason unless you want to control the narrative. And that's what they want to do. What's going on these days with the People's CDC? I don't know. You're talking about China's CDC? I have no idea. State and local public health agencies actually have the power. They don't use it. Well, the problem is, from my limited understanding, many of them get funding from CDC. So if they do something that the CDC doesn't like, they risk losing their funding. Okay, so yeah, they can do, in theory, they could test for polio, but the CDC doesn't want them to, so they won't. They don't want to risk losing their funding. Barb Mack, good night. Have a good rest. Thanks for being here. Really appreciate it. Pete says, I've seen the film Conclave. Can't give away the ending, but very pertinent to the current situation with POTUS 49. Okay, check that out. Conclave. Thanks for the recommendation, Pete. Yeah, that's right. Re-education camps for government employees who speak out. Right. Do you think RFK Jr. will go after the National Vaccine Injury Compensation Program? Yes, so he can. I mean, I assume that since it was signed into law by Reagan, Trump can sign an executive order to nullify it, right? So if RFK Jr. says, Donald, shut it down, he'll shut it down. That'll be the end of it. And then nobody will make vaccines anymore. And then we'll have chaos. We'll have to do it on a state-by-state basis then. Many states are not going to be up to that. Pretty scary, right? If you don't toe the line, would you choose getting fired or going to a re-education camp? Me? Well, I don't work for the federal government. But if I did, you're saying, well, I think I can make a difference by working there. So I'll go to a re-education camp. As long as I don't put electrodes in my brain, I can listen selectively, right? So I would stay. Or Hurling writes, do we know which agencies, organizations, institutions would have access to CDC data? Could universities ask them to share? No, they can't. They can't share anything with anybody. Even a collaboration can't do it. So anyone that gets any kind of data from CDC, NIH, FDA, not happening anymore. Maybe it's temporary. I don't know. Or maybe it's going to come back with some limitations, which is ultimately amount to censoring. It's just ridiculous to think of this, right? Rip the Comp, hello. Welcome back. I encourage anyone who may need boosters to get them ASAP before RFK Jr. starts investigations as a pretext on the way to stopping vaccination. Riptocomp is in Taos, where it's 10 degrees Celsius. John writes, the people who think science plotted to harm people are themselves now acting to harm people. Science doesn't plot to do anything. You can never get scientists to agree on anything. Everybody is their own person. Yeah, they're very individualistic. This idea that we have a conspiracy, this shows you don't have any idea about how science works. Elizabeth writes, state and local public health agencies are independent of the feds. Okay. But they also get information from CDC, which they're not going to get anymore. Okay. Sewer says, you will give unbiased health info. I've been listening for years before the pandemic. Yeah, we will. We're not going to introduce any bias. Anything wrong is a mistake that we make, which happens. But we will never do it intentionally. And so, yes, we'll keep doing this. We'll bring you the truth. We'll explain things, but we're small. And there has to be better ways. But Elena says, Blue Sky has a science feed just for scientists and science communicators. And that's another way of doing it, yeah. Rach says, I hope your top people relocate to the UK, Europe, or Australia for the next 4 years. Is Trump stopping them helping the world's health issues, so we need you to carry on elsewhere? Well, I don't want to leave. I'm staying here. I don't think leaving helps. It doesn't help me do what I want to do. A lot of people are leaving, but I don't want to do that. I want to combat it right here. Wikipedia is the last standing source uncontrolled by tech bros. Is that right? I don't know. They're not controlled by any big power like Google or Jeff Bezos or any multi-billionaire, really. Nobody contaminates or sullies them. I didn't know that. Well, if that's the case, then you can get information from them. Tanya Bro Shropshire, thank you for your contribution to science communication. If I remember, you're down in New Orleans, right? You got a bunch of snow down there. Everything okay? Anyway, we appreciate your contribution to science communication. Luis wants to know how you define a clade. Okay, so in virology, you take a virus here and it infects people, and it evolves and infects people, and you make isolates, and all the isolates related to that one is that's a clade. And then if you have a branch like Omicron, that's a clade, comes off, it's really different, and they have another clade there. So a clade is a series of viruses which by genome sequence are related to an ancestral virus. Yes, we have other countries, and they're going to do their thing, right? But they can't do anything here. They can't help us if we have an outbreak. We have to deal with it on our own. Is RFK in officially? No. His confirmation is next Wednesday, a week from today, I believe. All right, Spamlet says you should make sure to follow as many medical and political allies as possible on Blue Sky while they are still freshly building support. They don't prevent posting links like Facebook and YouTube do. Yeah, it's that's a good idea. I should. The thing is, yeah, I don't know why the other ones prevent you from doing links, but I guess that prevents harm as well. John, thank you for your support of science communication. Keep spreading knowledge. It's one thing that can't be taken away easily once you receive it, and Microbe TV has lots to distribute. Thank you, John, very much. I'm just trying to sort through all these comments. Future headline from Visto. CDC ordered to devote all resources to finding cure for woke virus. Sad this could come true. It's true. It's true. James says the COVID data tracker websites are still functioning, but they're not. They're not run by the U.S. unless you're talking about U.S. specific COVID. But they may not be updating. That's all. They're still there. It's old data. I don't know. Yeah. No, RFK has not had his confirmation hearing. No. To lighten things up, I do have a mini lecture I'll use to distract you. Is Resdora still your go-to? I haven't been to Resdora in a long time. I can't say it's my go-to. When I did go, which was now a couple of years ago, it was really, really good. But I haven't been since. I don't have a go-to place anymore. I don't go out to eat. Yes, this is good. When I worked briefly in scientific publishing, we couldn't even get scientists to agree what to get for lunch. This conspiracy mindset is so baffling. Yeah, totally. Costello literally lives on Twitch. I was on Twitch a couple of times during the pandemic. Maybe that's where you found me. I did a few streams answering questions. They were very popular. And I could actually stream this to Twitch as well. I could just co-stream at the same time. So right now this is going to YouTube, but I could also send it to Twitch. I wonder if that would be useful. Who controls ChatGPT? I don't know. Someone may know better than I do. But, this deal that Trump just announced with AI, billions of dollars, one of the people involved in that founded ChatGPT. It's a company that Musk hates. And he said that the whole deal is bogus. So it's a private company. Oh, not yet. Musk is heavily attacking Wikipedia precisely for that. How is he heavily attacking it? What is he doing? I see. Riz Carlton says Wikipedia isn't controlled, but they're vulnerable to data manipulation. So verify what you read. Elizabeth says, I don't mean to minimize the damage, but the more people turn to local health agencies, the more those agencies will take back their power. Most of them are public servants that very much care. That's true, but there's nothing like a national public health agency like CDC to coordinate things, right? Instead of having 50 independent health agencies do it. Abdur got his first paper published. Congratulations. What's it about? Tell us. Oh, yes. Thank you. You love that quote. If you do your best, sometimes you will resonate with someone. I have it over the top of my head. I just said it one night. And I remember your quote, Dr. Bro Shropshire. You said, I'll never forget it. Not all information has to be in your head. There's some information you hold in your head, and then there's information you know where to look for, something like that. You know what you said exactly, but I always remember that. Some information you keep up there, and the rest you know where to look for. It's really good. January 29th, RFK confirmation hearing. That would be, that's next Wednesday. As I said, I was right. Hello, Jill. Welcome from Wilmington, 11F. Spanless says, Vincent, read a Substack piece for The Contrarian. Just started this week by journalists and lawyers who just quit mainstream media en masse. You're just what they need. Do join them. I will look. Jill says the People's CDC is a U.S.-based grassroots organization made up of folks from public health, epi, science, and medical professionals communicating on mostly COVID, but other diseases as well. Oh, and so where do they exist? How can you read their work? They have a website, I presume, right? I see. They don't like links that take users away from their platforms, in essence. Well, this is disgusting. This is totally disgusting because it's all about freedom of information, right? And all you're interested in is making more money to staying on your platform. Now, I do take advantage of YouTube. Yeah, I do. I used to go to Vimeo and pay for it. There just weren't enough people. I'd pay for a service that was really good that didn't prohibit me from putting links in. It's ridiculous. Ridiculous. Questella found us on January 6th. I asked Google what a freaking virus was. That's very funny. Very good. Kang says, regarding big tech, Google Gemini and MS Copilot recommend that 76-year-old individuals should be vaccinated for COVID and wear masks in crowds. I agree with the masking. I wear masks in crowds. I don't know about immunization. I don't think it's necessary. But look, 3 months after you get immunized, you're going to end up getting more severe COVID. So you should take Paxlovid. So I think that's the thing. We got enough vaccines. If you test positive, take Paxlovid. We have to get over this mindset of physicians who say it doesn't work or it causes harm. It's not true. It does work. The studies are amazing. Go read them instead of watching football or playing golf. Yeah, I don't think Offit's going to be a witness. No, they're going to have crappy witnesses for RFK's confirmation. Is a clade like having a cousin named Billy Bob? Yeah, I guess it's your family. Yeah. ChatGPT gets major funds from Microsoft. Musk initially contributed $1 billion, but later withdrew. John writes, can a new SARS-CoV-2 variant fail to show up on a rapid antigen test? Yeah, it could if it's undergone amino acid changes in the nuclear protein, which is typically what's used there. No, maybe we're looking for spike antibodies. I don't even remember. Let's take a look. Let's look it up. Rat test. Maybe both spike and... Hey, Wikipedia. Let's see if it tells us what antigens are being used. False negatives due to new variant. Yeah, so spike. Spike is definitely in the rat. Sorry, so spikes typically identify the nuclear capsid protein. And that's much less likely to change, but it can, and it has before. So how would you check? That's a good question. So very few people are testing now anyway. It would be really hard to know, right? And I don't know what difference it would make. Dr. Bro Shropshire says we got 5 inches of snow in Terrytown, Louisiana. 10 inches in Metairie. We're fine. Trying to get the roads open. Thank you. All right. I see. Musk is saying Wikipedia has left-wing bias. It's trying to get certain users banned. Is attacking its funding, which is crowdsourced, and calls it Wokepedia. So that's the woke virus, huh? Abdur's paper was about using anti-GSK in mice model for removing neurofibrillary tangles for Alzheimer's. Interesting. We just did a I just did a TWIV on the role of herpes simplex reactivations in neurofibrillary tangles involving phosphorylated tau. Really cool stuff. I'm 76 in a couple of months, says Will. Well, you got 4 years on me. And then you got to go out and wear a mask and get vaccinated, right? Rach says, I'm off to Australia later this year for our honeymoon as I'm getting married this summer. Would you advise we wear masks on our 4 flights there and 4 flights back? I don't know anything about your health. If you're over 70, you should wear a mask. But if you're not and you have no comorbidities, then you don't have to. That's what I would do. So I'm over 70, I wear a mask on planes. Polka.pup wonders if Medicaid or Medicare will stop paying for vaccines. No idea. Does anyone know? We have people who are knowledgeable about this. Thank you, Ethan. Not Ethan. I'm going to call you GSD Bio. Jonathan. Jonathan. Yeah, the nucleocapsid protein. Exactly right. You shouldn't target the spike because it's too variable. Yeah. Okay, we have a pause in the questioning. Let's do a little mini lecture. Okay. Mini lecture. Okay, let me answer this question. Truth or dare? What do you mean when you said after 3 months you get more severe COVID? Okay, so you get a vaccine. You have high levels of antibodies for a couple of months. I should say 3 months, but it's going to vary depending on you, who you are, your genetics. Then your antibody levels are going to go low. And then when you get infected, you're going to have more replication and possibly more severe disease, right? So unless you're going to get vaccinated every 3 months, you can't avoid that. What do? You take Paxlovid, right? So if you're over 70, I think, yeah, if you're over 70, you can get it. I do not wear an NIOSH certified N95. I use a KN95. That's it's a compromise, but that's what I do. But yeah, mask on the plane, spending your honeymoon with COVID. Yeah, you can take your choice, right? Maybe you should mask. All right, let's do a. What am I doing? A mini lecture. I'm amazed that I didn't do this before, but let's talk about attachment and entry. Why did I say that? Because my lab used to work on receptors. We were really into them. So, viruses are obligate intracellular parasites. They have to get inside of a cell to reproduce, but they're too big to simply diffuse across the plasma membrane. And so how do they get in? Well, they bind receptors on the cell surface. Most viruses do this, not all. There are some exceptions. So viruses are bumping around into things, and they're random collisions, and sometimes they hit a specific receptor that they bind to with high affinity, and then somehow the genome gets into the cell. And we'll talk about how that happens. So this These receptors are important to understand and identify. They are essential for all viruses except those of fungi, where the viruses don't go outside of the cells. They remain in cells, and they go from cells to cell when they divide. And plants. Plants get infected by mechanical damage. And this is a relatively new field. In 1985, only one receptor was known, sialic acid, for influenza viruses. That's influenza virus binding to its receptors. So how do you know you've got a receptor? How do you know it's the right thing? Here's some criteria. First, you have a protein, a cell protein, and you show that it binds the virus particle. You could make an antibody to your receptor and show that it blocks infection. You could clone the gene for the receptor and show that if you put it into cells, it will confer susceptibility. And that's a little iffy because sometimes you need more than one receptor, so putting one in may not work. You have to get around that. You could also disrupt the receptor gene, and that would block infection. So all these are good criteria to have to show that you actually have a receptor for a virus. So here's a great experiment. Came out beginning of 2020, and it showed that ACE2 is the receptor for SARS-CoV-2. So let's go do this. So we start with HeLa cells. And HeLa cells don't make ACE2. Now, ACE2 is known to be a receptor for other coronaviruses, so people said, let's see if it is a receptor for SARS-CoV-2. So you take some plasmid DNA encoding ACE2, so the gene for ACE2 is on this plasmid. You put it into HeLa cells. Now you have HeLa cells that produce ACE2. Okay, so that's an essential reagent for this experiment. And then we infect cells with SARS-CoV-2. And these panels here are immunofluorescence experiments where we're looking at, so DAPI looks for the nuclei, so you can see that you have cells there. Okay. And here we're staining with an antibody to ACE2, so it's going to be green. And you can see HeLa cells don't make any green. They don't have ACE2. And so here we have our human ACE2 cell line that we made here. It's green. And this is a HeLa cell that was made that has bat ACE2. You can see that's being produced. And here's HeLa cells with mouse ACE2. And so that protein's also being produced. So you infect these cells with SARS-CoV-2. You add virus to them. And then you add an antibody to the nucleoprotein to see if the nucleoprotein is made, which would be an indication of infection, right? And then that would show up red. So nucleoprotein is made when the cells are infected. So HeLa cells, which don't have ACE2, you see there's no nucleoprotein made. So these cells are not infected. There's no receptor. But when you put the human ACE2 into HeLa cells, now you can infect them with SARS-CoV-2. The bat ACE2 also works. But interestingly, the mouse ACE2, it doesn't work, but you can make a few amino acid changes in either spike or the receptor, and you can get infection. So that showed that ACE2 was the receptor. It was easy, though, because we already knew it was a receptor for other coronaviruses. It's hard when you have to start from zero. Okay, so we've identified lots and lots of cell receptors for viruses, and there are all kinds of cell surface moieties, proteins, glycoproteins, transmembrane proteins, sugars, heparin sulfate proteoglycan, gangliosides. You can see a list of them here. And what viruses, so here's the poliovirus receptor, here's HIV-1, two different receptors for HIV-1. So we have lots of identified receptors for viruses, and we can study them, their interaction with the virus and how they lead to infection. Yes, Jeff says, and we have to pause to highlight this. Adding the ACE2 receptor to HeLa cells is an example of gain of function, right? Absolutely. It's a gain of function experiment that nobody would worry about. Yet the Republicans all lump all gain of function into one nasty bag. They don't get it. Oh, maybe they do, and they just want to make a political point, right? Yes, so any kind of new function, in this case, we've given HeLa cells the ability to make ACE2. That's a gain of function. Good point, Jeff. Thank you very much. Okay, so it's not always one virus, one receptor. Different viruses can bind the same receptor. And here, the adenovirus and Coxsackie virus B3 have a common receptor called the Coxsackie virus adenovirus receptor. So this Coxsackie viruses, which are shown in the middle here, were named after Coxsackie, New York. This is where one of our listeners lives who wants my father's microscope. Here's exit 21B on the New York State Thruway, Coxsackie. And there was an outbreak of what looked like a polio-like illness there in 1947. And they thought it was polio, but it turned out to be a new virus, Coxsackie. Anyway, these two viruses bind the same receptor, and a swine herpes virus can bind the same receptor as poliovirus. So they're not unique to each virus, okay? And viruses of the same family can bind different receptors. So rhinoviruses, there are 3 different receptors. Retroviruses, there are at least 16. And in addition, one virus, here's herpes simplex 1, can bind multiple receptors. It's got multiple glycoproteins on the virus particle. It can bind multiple receptors. Okay. How do virus particles attach to receptors? Here are a couple of examples. Here's poliovirus and rhinovirus. And what we're looking at is the structure of the viruses bound to the cellular receptor. So here's poliovirus schematically shown on the lower left. The receptor fits into a groove, which is around the 5-fold axis of symmetry. I know you all remember 5-fold axis because we did a structure mini lecture a couple of weeks ago. And this is the receptor CD155 binding to the canyon, which is what it's called, around the 5-fold axis. And here is the structure of poliovirus bound to many molecules, 60 exactly, of the receptor, each one binding in the groove around the canyon. All right, and you'll see that picture quite often. In fact, it's the TWIV logo. It's poliovirus bound to its receptor. Now, rhinovirus is slightly different. The receptor doesn't bind in this groove. It is binding on this plateau. So there's a plateau at the 5-fold axis of symmetry. And that's where the receptor for some rhinoviruses bind. So protein-protein interactions. Now, there are other ways that this happens. Adenovirus has these fiber proteins sticking out from each 5-fold axis of symmetry. They're shown here, pulled out of the virus particle. But the very knob, the distal part of the fiber, binds the receptor, Coxsackie adenoreceptor CAR, by sitting right down on top of it. Another protein-protein interaction mediated by these fibers. Now, membrane-encased viruses do it slightly differently because they always have glycoproteins in the membrane. So here's the influenza virus particle. And it's got an envelope surrounding the genome. And within the envelope are, of course, multiple glycoproteins, HA, NA, and then the M1 protein. But the HA is the one that attaches to cellular receptors. So here's the structure of the HA right here, bound to the viral membrane. The top portion has a groove in it into which sialic acid binds. So we're looking down here on the top of the HA molecule, and you can see sialic acid is fitting in that groove and making interactions with amino acids lining the groove. The sialic acid is a sugar that you find attached to glycoproteins, and that is the receptor for influenza viruses. Here's a little more information on sialic acid, because if we do have an influenza virus pandemic, which we will. It doesn't have to be H5. It can be something else that we're not looking after. You'll hear a lot about sialic acids. So sialic acid is typically the last sugar on a chain of sugars attached to proteins. So proteins embedded in membranes are typically glycosylated. They have sugars attached to them. We call them glycoproteins. And sialic acid is the last sugar. So if you have sialic acid as the last sugar, then there's a sugar next to it, and it has to be covalently bound to that sugar. And the nature of that linkage determines what kinds of influenza viruses actually bind to the sialic acid. So here, for example, we have the sialic acid linked to the next sugar, which happens to be galactose, by an alpha-2,3 linkage. All that means is that there's an oxygen linking the number 2 and the number 3 carbon. This is the receptor for avian influenza viruses, alpha-2,3 linked sialic acid. Whereas sialic acids linked by an alpha-2,6 linkage to the next sugar are receptors for human influenza viruses. So, for example, avian H5N1 influenza virus preferentially binds alpha-2,3 sialic acids, which we do not have in our upper tract except in our eye. That's why a lot of these individuals get conjunctivitis. If you're going to get a respiratory infection, you have to have the receptor in the upper respiratory tract. And we do not have alpha-2,3 up there. It's way down in our lung, so it's really hard for H5N1 to infect people and to be transmitted. Hard to transmit from the lung. Transmission occurs from the upper tract. You're shedding virus-laden fluids from the upper tract. So that's a primary change that has to occur for an avian influenza virus to become a pandemic virus. But it's not the only change. All right. HIV attaches to its receptor in a similar way. Here's the HIV particle, and it has spike glycoproteins which attach to a cellular receptor. One of the receptors is CD4, shown here, and here is the spike glycoprotein binding directly to CD4. And finally, we can't leave out SARS-CoV-2, right? How does SARS-CoV-2 attach? So we know that the SARS-CoV-2 receptor is ACE2, right? And here's a chart of the coronavirus cell receptors. What else binds ACE2? SARS-CoV, the first one, and the human coronavirus, the common cold coronavirus, NL63. So the virus, SARS-CoV-2 binds the spike on the cell surface. SARS-CoV-2 spike binds ACE2 on the cell surface. And here is a structured diagram of that binding. And so here is the spike protein, and in green is what's called the receptor binding domain, which is the part that binds the receptor. And on the right, you can see now we have put ACE2 in here in red, and it's binding the receptor binding domain. So that's exactly how the spike protein binds ACE2. Okay, so that's all about binding, but the viruses need to get into cells, right? And there are lots of ways that cells take up things. There's phagocytosis for big particles. There is macropinocytosis, taking up liquids. And then there's receptor-mediated endocytosis, where ligands bind specific receptors and then are taken up in the endocytic pathway. Now, the cell cytoplasm is very crowded. Things don't just diffuse. Here's a lovely picture by David Goodsell. Starting from the plasma membrane, you got actin microfilaments, you have tubulins, you've got ribosomes, you have endoplasmic reticulum. Here now we're moved to the nuclear pore. These are successive panels going from the plasma membrane down into the nucleus, and finally we get into the nucleus. So it's really crowded. You need to have energy-dependent pathways to move virus particles in the cell. And there are many ways of viruses getting into cells summarized on this picture. We have viruses, envelope viruses, fusing at the plasma membrane and depositing their capsid into the cell. You can have virus particles taken up by endocytosis. There are many kinds of endocytosis, but eventually the particle gets out of the endosome and moves towards where it has to go. And here's a nice movie of a endosome moving down a microtubule by a motor protein. So things move along microtubules in cell by these dyneins and kinesins, which are motor proteins. And this is a big endosome here, and it's pulling it along. The point here is that movement is always powered, and it requires energy. You just don't diffuse. It would take forever. This is a lovely animation, isn't it? Some viruses enter at the plasma membrane, so they can bind the receptor, and the viral and cell membranes will fuse, and then boom, the nucleic acid is there into the cytoplasm of the cell. So what's the trigger for this fusion? Well, there can be a couple. Here they're diagrammed at the bottom. So paramyxoviruses like measles virus, they have an attachment protein and an F protein or fusion protein right next to it. So the attachment protein binds a receptor in blue. That causes a conformational change in the fusion protein, which flips it around and inserts the fusion protein into the membrane. So the fusion protein has at its end terminus a series of hydrophobic amino acids. They can stick into membranes, and then they will pull the viral and cell membranes very close, and they will fuse. Here's the way HIV gets in. Again, the viral glycoprotein. There's also a fusion peptide next to it. The glycoprotein first binds the CD4 receptor, and after that it can bind the second receptor, the chemokine receptor. And then finally, only after those two receptors are engaged, does the fusion protein flip and insert into the membrane. So we have a couple of animations here. Here's the HIV glycoprotein-mediated fusion. So here's the viral membrane, and the glycoprotein has extended its fusion peptide into the cell membrane. It acts as a trimer, as you can see here. As the virus moves into the cell, so this extended conformation of the glycoprotein, where the fusion peptide is inserted into the cell membrane, this is not energetically favorable. The protein would rather be in its original conformation, which is like this, alpha helices. And so it reforms, and in so doing, brings the membranes together so that they can fuse. And first one set of membranes fuses, and then the second fuses. But it's all because this conformation is not energetically favorable. The glycoprotein wants to go back to its native conformation. It does so, and in so doing, it causes fusion. Now, again, it's not diagrammed very well here in terms of a hairpin, so I'm not going to show that to you. But you can see it on influenza virus. It's the same principle. Influenza virus binds receptors, salicylic acid receptors, taken up into endosomes. We think that HIV entry that I just showed you occurs at the plasma membrane, as I told you. As the endosome moves into the cell, the pH drops. The pH drops in the endosome, and that causes a conformational change in the hemagglutinin, which is the receptor that has bound to sialic acid. Now, the fusion peptide in the beginning is this red bit here that's hidden near the viral membrane. As the pH drops, the whole HA protein reorients so that that red peptide is now extended and shoved into the cell membrane. So this is the extended conformation of the HA. It's like a hairpin made straight. Similar idea for HIV glycoprotein. But this HA doesn't like to remain in a unfolded hairpin. It wants to be a hairpin. So it comes back together, and in so doing pulls the two membranes together. They fuse, and then the viral RNAs can get out of the endosome. So I love this metaphor of a hairpin. The native protein is in a hairpin conformation. At low pH, it becomes extended, but it's not energetically favorable. So it refolds, bringing the two membranes together. I think it's just beautiful. So there are three states of the influenza virus hemagglutinin. We have the native state, which is in the form of a hairpin, and then we have the low pH state, which is it shouldn't be a hairpin here; it should be an extended hairpin. And one of them wants to come. This is the energetically stable one, and so even though low pH makes an extended conformation, it comes back to form a hairpin. Here's an animation of influenza virus entry. So the virus binding to sialic acid is being taken up into an endosome. There's the endosome forming, and it will move into the cell along microtubules. In the process, of course, the endosome is becoming acidified. Here's it moving on the microtubules. This protein coat on the endosome comes off, and the influenza virus glycoproteins fuse with the membrane of the endosome, and out come the RNAs of the virus, and they go into the nucleus. So this step in virus infection is very amenable to animation. So when we're talking about entry, we have to talk about SARS-CoV-2 entry and hydroxychloroquine. So remember, the virus can bind ACE2 at the cell surface. Now, if it's a respiratory epithelial cell, there's a second protein present on the surface of those cells called TMPRSS2, and that is a protease that will cleave the viral spike glycoprotein right at the surface, so that the virus will fuse with the plasma membrane at the cell surface and deposit the RNA in there. So that's the way the virus infects in cells with TMPRSS2. Many other cells do not have TMPRSS2. And in fact, the people who discovered that hydroxychloroquine inhibits SARS-CoV-2 entry used a cell line that did not have TMPRSS2. Okay? And in a cell line without TMPRSS2, the virus is taken up by an endosome. And in the endosome, the spike is cleaved by a protease called cathepsin. That allows the virus to fuse from within the endosome. Hydroxychloroquine inhibits this protease, but has zero effect on TMPRSS2. So while hydroxychloroquine worked in cells in culture, there was no way it was going to work in people, because in the respiratory tract, the virus does not go near an endosome, and so hydroxychloroquine cannot work. But none of the people involved in approving hydroxychloroquine bothered to study the biology of infection. And so Trump forced the FDA to approve it, and it caused damage to a lot of people. It's all about biology, folks. You have to just look at the data. So those proteins we've talked about are called class 1 fusion proteins because they're perpendicular to the membrane. They have some other properties. They're also class 2 fusion proteins, which are lying flat on the membrane, yet they can still work as fusion proteins. When the pH drops, they extend, then they hairpin and bring the membranes together, and you get fusion. Now, you've seen these viruses: dengue virus, Zika virus, yellow fever virus. They all have class 2 fusion proteins. Here's a model of dengue virus entry. These are the class 2 fusion proteins laying flat on the virus surface, not perpendicular as for flu and HIV. The endosome is moving along the microtubule. The endosome is acidifying. So now the glycoproteins are standing up. The fusion peptides are standing up, and they're going to insert into the endosome membrane. We're going to see that in a moment. There you go. There's the fusion peptide at the tip being inserted into the endosome membrane. Now they're going to hairpin, right, because they don't like to stay in the extended conformation. And that brings the two membranes together. They are fused. So getting membranes to fuse is only a matter of getting them right next to each other and excluding the water molecules. If you can do that, they'll fuse, and out come the viral RNAs you can see here. And they are plus-stranded RNAs, so they can be translated directly into the cytoplasm. So that's an example of a class 2 fusion protein. A couple of more examples of how viruses are, how genomes are released from non-envelope viruses. We've been talking about envelope, where it's conceptually easy, the membranes fuse, right? How are genomes released from non-envelope viruses? Well, adenoviruses bind their receptors, are taken up into the endosome. And as the pH drops, there is a little protein in the capsid called protein 6, these little yellow diamonds. They come out of the capsid and they poke a hole in the endosome. And that's how the virus particle gets out. It then rides the microtubule down to the nuclear pore complex, where it puts its DNA into the nucleus. And at the nuclear pore complex, a very cool thing happens. You see, here's adenovirus docked on the nuclear pore complex, right? It's brought there by a motor protein. It's still stuck to the motor protein, but it's also stuck to the nuclear pore. Well, you know what? The motor protein is on its way back to the plasma membrane to pick up other cargo. So it breaks the adenovirus essentially by pulling one way while the virus is attached to the nuclear pore. And that liberates the viral DNA, and it can get into the nucleus. It's very cool. Poliovirus, another problem, right? It's a capsid, a pure protein shell. How does the RNA get out? Well, the virus binds its receptor. It's taken up into an endosome, but shortly afterwards, the receptor forms this umbilicus between the endosome membrane and the virus particle. It's basically a tunnel formed by the receptor, and that lets the RNA come out. Noroviruses are the same. Caliciviruses, upon receptor engagement, here's the virus capsid without the receptor. And when you add the receptor, it forms a portal at one end of the virus particle. There's the portal looked at from the top and from the side. And the RNA comes out of this portal and goes into the cell. Very cool. And finally, reovirus is an interesting virus. It has two shells. It binds receptors taken up into the endosome. It actually remains in the endosome as the lysosome fuses with it, and that delivers proteolytic enzymes, which remove the outer shell of the virus particle, and that makes the particle hydrophobic, so it can penetrate out of the endosome and into the cytosol. Very interesting. So many ways viruses can get into cells at the cell surface throughout many different kinds of endocytosis. And people studying these can learn about what works and the mechanisms, and perhaps design inhibitors. I want to just tell you one story which is really interesting. And this is about how receptor polymorphism can control susceptibility. So rhinovirus receptors, there are a bunch of serotypes that bind ICAM1 as a receptor. There's some that bind low-density lipoprotein. And then HRVC genotypes bind a protein called CDHR3. So here we have the three rhino receptors, ICAM1, low-density lipoprotein, and CDHR3. Okay, so CDHR3 is a human protein. It's been known for some time that a single amino acid change is associated with increased risk of wheezing illnesses and hospitalization for childhood asthma. And so a change at amino acid 529 to a tyrosine from a cysteine, is associated with asthma. And studies of this change showed that cells that have the 529Y amino acid change have tenfold higher increased protein and rhinovirus C binding and yield. So in other words, the risk factor for wheezing and asthma is because is really good. This 5291 is really good at binding rhinovirus. Okay. In 2013, there was an outbreak of Rhino C in chimpanzees in Uganda. And some of them, like Betty here, died, unfortunately. All of the chimps had 529Y. They sequenced their genome. They have the susceptibility amino acid. Only humans have 529C. Denisovans, Neanderthals have 529Ys. Chimps have 529Ys. So what's going on? If a virus infection is sufficiently lethal, over time, over evolutionary time, there will be selection for changes that attenuate that virulence. And in this case, from Neanderthals and Denisovans to humans, we've selected humans to have 529C, which gives less Rhino C and less lethality. But the other species have not had time. They don't contact the virus, so there's been no selection. Chimps don't see Rhino C. In this case, the outbreak was caused by tourists going to the chimp preserve and giving them the virus, unfortunately. So it's an interesting example of what receptors can do. Okay, I know there are a lot of questions here, so we will do those for the rest of the time. All right, where are we? All right, now, gallbladder, you're misinterpreting what I said. If you have a vaccination, you have a rise in antibody titers. Those antibodies will reduce virus replication to a certain extent and modify the disease pathogenesis, all right? You'll have less severe disease. But antibody levels do not stay high for long periods of time. They decrease over a few months. So in 3-4 months, you're going to be in a position where you no longer have high serum antibodies induced by the vaccine. You're going to depend on a memory response when the virus infects you to make antibodies. The memory response is a few days delayed. And so the virus is going to get a foothold, you're going to get replication, and you could have moderate disease, even severe disease, depending on what other illnesses you have. But the point is, when you have high serum antibodies, you are protected against moderate disease and severe disease. But those high levels do not remain for more than a couple of months. That's what I meant, okay? And yes, the hair pinning, you saw it there. There you go. Hello, Vanity. Thanks for saying hello. As you see, we made our office hours here. So Kang wants to know, is Tamiflu a competitive inhibitor for the sialic acid receptor? So there are two glycoproteins on the influenza virus surfaces, the hemagglutinin, which we talked about quite a bit, right? And there's also the neuraminidase, which is an enzyme, and that the substrate for the neuraminidase is sialic acid. And so Tamiflu is an inhibitor of the neuraminidase, and it fits in the enzyme active pocket. So yes, it's a competitive inhibitor of the neuraminidase, not the hemagglutinin. Right, so Mandrake says Tamiflu blocks the enzyme that cuts sialic acid, right? So you like these animations. I'm glad to hear that. There is a COVID drug that shut down the microtubules, sabizabulin, right? Daniel talked about this, all right? It is a microtubule inhibitor. So it inhibits tubulin polymerization. So it's going to be inhibiting the movement of viruses and subviral particles in the cell. Now remember, it doesn't have great clinical efficacy. How does it work? SARS-CoV-2 in lung cells fuses at the plasma membrane. It doesn't need to go on a microtubule, although the nucleocapsid, when deposited at the plasma membrane, may move along a microtubule, and so maybe that's why it inhibits infection. Yeah. Okay, how much does air exchange really matter for COVID-19 transmission? So the problem is, on airplanes, they have this wonderful top-down airflow with HEPA filters. That's great. But then you have people sitting next to you and in front of you, and people walking up and down the aisle. So all the great HEPA filtration is kind of out the door when that happens. So if you're worried, you ought to wear a mask on a plane. Yeah, those are good animations. I'm glad you liked them. And people are getting tired here. I understand that. Okay, Mandrake, did the people that did the cell culture test retract their paper after they found they used the wrong cell line? Oh, no. In fact, the guy on that paper was Didier Raoul, the scientist in France who's been under all sorts of trouble for data fraud. And so, I mean, the observation was right. It inhibits in cells in culture where the virus goes into the endosome. There's nothing wrong with that. But to extrapolate that to people is ridiculous. And that's what they did. They said, oh, we don't need any clinical trials. We're just going to use it in people. Because it is hydroxychloroquine is approved for some other treatment. So you can do an off-label, right? And it didn't work, and people got sick. They had side effects that were miserable. Yes, it's really helpful to hear that the cytoplasm is crowded and it takes more energy to move around. Yeah, most people think it's empty, right? And things diffuse. But no, things do not diffuse. It's too crowded to diffuse. It would take hours for a virus to go from the plasma membrane to wherever it has to go. Hello, Joseph from, I think, Ontario. You were at Tweevo today. Don't worry about being late. It's okay. Dr. Griffin talks about Tamiflu and other treatments for flu in the last Puscast. Yes. For Tamiflu, you have to take it early enough. But Xofluza, the other drug, is much more forgiving, and you only need one dose. So I don't know why people aren't using that. Costello's worried about being attacked for wearing a mask. Yeah, I can see where you might be attacked. I've never had anyone say anything to me, but I'm ready. But I could see where people might attack you, and you just have to say, I'm sorry, I don't want to get sick. That's why I'm wearing a mask. Ariozone, this is a chicken and egg kind of question. Any way to know if viruses preceded multicellular life hosts or the other way around? Okay, here's the current theory. In the beginning, when Earth, billions of years ago, before there was any cellular life on Earth, there were pools of self-replicating RNA molecules. So this was after quite a bit of chemical evolution happening early in the Earth. Again, pre-cellular days. So these are early pre-viruses. They're just RNA molecules that can reproduce themselves. So that's the beginning of everything, we think. So, but it's RNA world. There's an RNA world where RNA has all kinds of fantastic properties, including self-replication. And eventually, it gets the ability to make proteins. And how that happens, we don't know. But then when you get proteins, then you could start building simple cells. And then when you have proteins, one of those proteins can be an enzyme that copies RNA into DNA. So now you have DNA-based organisms, okay? So you're making cells with DNA, and they're getting bigger and bigger because with DNA, you can encode a lot of proteins. Now these RNAs, these self-replicating RNAs are outside the cells. They're replicating, in the organic soup, and they're like, why are we out here? It's much nicer inside that cell. So they go inside the cell where it's much easier to replicate. And then they go, oh, look, there's a protein in this genome that can form a capsid. Let's steal it, leave the cell, and go infect another one. Okay, so that's a terribly anthropomorphized version of how viruses arose initially and how cells arose from them. Yeah. You like these animations. Yeah, books can't do justice to it, but animation is great. So is that two-way selection pressure on the host species? So the ones with C survive, then with Y, and also on the virus. So I don't know. We're not aware of any virus selection. You can imagine that if the host evolves a C, which puts less protein on the surface, maybe the virus can still reproduce sufficiently with that reduced protein. If not, you can imagine that the virus could change in some way to increase its efficiency at infecting cells with lower levels of the receptor. So yes, you could definitely go back and forth for sure. Visto, what are all those receptors doing? Oh, each and every one of them has a cell function. You can bet on that. They're not there for viruses. They have all kinds of functions, immune functions, adhesion functions, transporter functions. They were just, they were there and viruses bumped into them and it worked. But they're not there for viruses, yeah. So Ripticomp likes TWIV 714 with Jason McClellan. It solved the spike structure of SARS-CoV-2 very early on. Yes, it was very good. Will says, as a layperson, there's not much that I understand, but it was helpful to learn that we can learn a lot from studies of mice, but need to recognize that human biology is different. Yeah, that's an important takeaway message. In fact, all animal models are not humans. They are surrogates, and you have to understand that when interpreting the data. I'm sorry, Costello, that you had trouble last year wearing a mask. And she says, I know if I'm shedding, I'm going to wear a mask. I don't want to be an asshole. And that's the way to be. Can viruses that have glycoproteins on their exterior use these sugars as a form of camouflage for the immune system? Yes, there are examples of where sugar molecules, so you can have a mutation in a glycoprotein gene that now puts an amino acid in that will be glycosylated, and now that interferes with an antigenic site. It interferes with antibodies binding. So mutations that cause antibody escape don't have to be to change the amino acid so the antibody can't bind. It could be a neighboring amino acid that puts a bulky sugar in so the amino acid can't get in. Super Bowl. I don't even know who's playing in the Super Bowl. No idea. I don't know who won the World Series. Have no idea. Sorry. Weasel had a lady rip one off in a store. It's not good. What's wrong with people? People shouldn't touch other people. That's wrong. Yes, the filtration is not switched on during boarding and deboarding. Right. I think it's, you have to ask Vanity. It's doing pushback. Right. Pork has sialic acid. Everything has sialic acid. So not really useful for flu prevention. Yeah. Yeah, antivirals work really well for acute infections in the first few days, right? An acute infection is one that is over in a fixed amount of time. A chronic infection, herpes, HIV, hepatitis B virus, you have plenty of time to treat with an antiviral. So this restriction does not come into play. No. I know who's playing in the Super Bowl football teams, right? So I really do not know. I don't pay attention to sports. Manuel says, what would be the best approach to identify a receptor for a virus whose receptor is unknown? Okay, so this is what I would do. I would take a cell line that can be infected by your virus, right? And then do a genome-wide CRISPR knockout scan. So you get a CRISPR library and you put it in the cells and you infect with your virus and you look for the cells that survive because the CRISPR has knocked out the receptor gene. And then these CRISPR knockout libraries are usually barcoded. So you could go into those cells that survive and identify the gene that's been knocked out. So that's the way I would do it. All right, I think it's time to wrap this puppy up, put it to sleep. I appreciate all the participation. I hope you learned something. Thanks to our moderators, Les and Vanity Nutrition, and Barb Mac UK was here for a while, and Steph SF was here. Les was here. I think I mentioned Les. Tom was here. Thank you all for being here tonight. Appreciate your moderation. And we have 178 people, 156 likes. If you haven't hit the like button, please do so. It helps attract other people to these programs. And we do need other people to listen in and hear what science is and why you can't say that vaccines don't work, and you can't say other stupid public health things. So here you can learn about this, and we want other people to find out as well. We'll be back next Wednesday. That's the day of RFK's confirmation hearing, right? That is Wednesday, January 29th. Be back at 8 p.m. Eastern for another office hours. Thanks for everyone for coming. I really appreciate it. I like spending the time with you, and I like teaching you, honestly. So have a good week, folks. Be safe. See you next time. Good night.